decided to spare you my QD on Monday.
Yeah, so you weren't feeling well, huh?
No, and I missed yesterday too. It was
Oh
so
my
bad.
gosh.
Yeah, it was rough. All right, I'll be right back.
Okay.
In a few minutes.
Fine.
Hey, Miss Shawnee.
Hey.
Do you know a list of schools that were at the college fair today?
There are a lot of them, but I don't know the list of them.
There was a list. I just put the table, like over here, at these offices, or in the where you like sign in.
I wonder if online, when they gave you the information about that, I wonder if they listed the schools maybe on the promotion.
Do you want to know the specific schools? Yeah, I was wondering that. Did you go? Did you say that?
Miss Evans told us that.
No, she said, well, I'm guessing it's just AEC, but I have the list. I was like, well, what's in the list?
What was the other school?
And then I forgot. I don't think they were there. But, and she's taking.
You're good whenever you want to go.
Oh, okay.
Yeah, one was about their, like, agricultural and life sciences.
Okay, guys. So at the end of our last class, I worked a system of equations, and I showed you the substitution method, and I showed you the elimination method. I also talked about how graphically what is happening is it's showing you where these 2 points or these 2 lines intersect at this point. So I went into Desmos.com, which maybe you're familiar with, or if not, it's a great site to go to whenever you need to graph anything. So I went to Desmos.com and I typed in the 2 equations we were using at the end of the last class. So I just typed in 3x plus 2y equals 11 and negative x plus y equals 3. It graphed it for me, and it's really great because I can click right on it, and it tells me that the coordinates of the points where they intersect is at 1, 4. And if you look at the homework, I mean,
Can't see anything.
Can't see.
Now we can.
no, you
Can you
can't.
Can you see it now? Yes.
Okay, so we get the point 1, 4, and that was the same answer that we got on the problem that we worked at the end of class. All right, so what I'm going to show you now is sometimes the 2 lines will intersect, like with this one. And then sometimes the 2 lines will never intersect. And if the two lines never intersect, they would have to be parallel. And what that would mean for our answer is that we would say the empty set. Okay, and I'm going to show you an example of that and what it would look like if we get the empty set. But I just want you to have a visual of if you're going to get the empty set, what it means is the two lines were parallel. And then, so you have choices. Either two lines are going to intersect at one point, they're never going to intersect, or those two lines would actually be the same line. So you look here, and actually the first line and the second line, when you graph them, they're right on top of each other. They're the same line, all right? So this would mean there would be infinitely many times that they would intersect. And I'll show you how my math lab expects you to put that answer in too, all right? Now, I told you last time that we were going to learn how to solve these by using our calculator. Now, before I do that, what you're going to need to know is how to make it look like a matrix. Right? So, for example, let's start back with the one that we've already worked. So, this problem is 3x plus 2y equals 11, and then minus x plus y equals 3. So, that's the same problem we've worked a couple of times. What we want to do is we want to put it in matrix form. And what a matrix form means that I want to do is you have to first make sure that your x's and y's are lined up and that your numbers that don't have an x or y are on the other side by themselves. Okay, so it has to be in this display before you can put it in a matrix form. So to put it in the matrix form, once everything's lined up like it's supposed to be, then all you're going to type into your matrix or write into your matrix is the coefficients. So on the first row, I would have a 3, a 2, and then an 11. And on the second row, I would have a -1, a 1, and then a 3. Okay? So I've created a matrix. So a matrix has rows and columns. And the way this one is set up is this column represents my x's, this column represents my y's, and this column represents my constants. Okay? So it has to look like that for this to work. We're going to put this in our calculator, and I'm going to show you how. And RREF, this is called reduced row echelon form. You don't have to know those words, but I'm just telling you what the RREF stands for. It's called reduced row echelon form. And what it's going to do is it's going to turn this matrix into a bunch of zeros and ones. So my answer is going to have a 1 here with a 0 there, a 0 here with a 1 there. That's what it's going to look like. And then there'll be a number here and a number there. And remember that this was my x column and this is my y column. So in this row, it's going to tell me what the x answer is, and the x answer is going to be whatever that number is. And then for the y's, this row is going to tell me the y answer, and it's going to be whatever number is there. Okay, so that's the process that I'm going to go through. So now I'm going to show you how to do this on your calculator. So I'm going to go to the overhead, and we're going to need, oh, this is low batteries. Let's hope my other one doesn't say low batteries. So you want to make sure that you have your calculator, right? Okay, and we're going to want to live in the matrix world. So we're going to do second, and then there's x to the 1 there, or to the -1. That's going to be.
You're not seeing it?
No.
Now?
Yes.
Yes. Okay. Great. So all I've done so far is I hit second and then x to the -1. The word matrix is written right above that. Okay. Let's see. Okay. All right. So once I've done that, now I need to tell it how big my matrix is going to be. So when I look at my matrix, I didn't bring any extra paper. All right. Can I come back over to this screen? I'm going to jump back and forth real quick.
Yep.
All right.
Just give me time.
Okay. So next I'm getting ready to tell you how to know how big your matrix is. When you tell them how big your matrix is, you're going to put the row times the columns. So here I have 2 rows. So this would be a 2 by 1, 2, 3, 3. All right. So it's a 2 by 3. 2 rows, 3 columns.
You see it now?
No.
But you're going back to that now, though, right?
Yeah, I'm going back to this now. So hopefully I'll...
The computer.
Can you see the calculator?
No.
Now?
No.
The old-fashioned way.
Okay. Here we go. Okay. So the matrix that we have is going to be a 2 by 3. So depending on what size matrix you'll have, where it says names, you're going to come all the way over to where it says edit. So you're going to take your arrow key and go over to where it says edit. Okay? And then we're dealing with number 1 here. And if I hit enter, you see I'm talking about matrix A, and it's a 2 by 3. So it's already set up to be the size that I need it to be. So it's a 2 by 3. And now as you keep hitting enter, you're going to start putting in the values. So I've already put these in. You have a 3, and then you hit enter. And then you type in 2 and hit enter. 11 and hit enter. -1, 1, and 3. All right, so once I've done that, all my numbers are in the matrix. Okay, so now I want my calculator to do the work for me. So I go back to hitting second matrix because now instead of just editing it, I want it to work. So I'm going to move over to where it says math. Okay, so once it says math, I'm going to arrow down, and yours may be at a different number than mine depending on what calculator you have. But for me, I'm going down to B. Yours may be at a different number. But I want RREF, not just REF, but RREF. That's the reduced row echelon form, right? And I'm going to hit enter. Okay, so see at the bottom it says I've got a 2 by 3 matrix. I might need to clear that. Do I have to quit? Let's see. Here's my quit. Yeah, so I didn't want anything to be in front of the RREF, okay? So I just said quit, cleared it out, so that all I'm going to have on there is RREF, and then I'm going to tell it which matrix I want. I want the first matrix, and then I'm going to hit enter. Notice what it looks like, 101014. So what that means is, remember, our first column is our x's, all right? So this says the x is a 1, and the second column is our y's. The y is a 4. Do you see how that is the answer we got earlier? So when I write my answer, I would write it as a point, 1, 4. All right? So this is telling me graphically, if I graph them, that's the point where it would intersect. It's telling me if I plugged in a 1 for the x and a 4 for the y, it would make both of those equations true. All right? And I don't know how to make it any... busy. Ooh, maybe that's better.
That was in the way.
Then this is in the way. Okay, well, I'm trying. Okay, so does anybody have any questions? We're going to keep doing this over and over. But does anybody have any questions so far? So the first thing you have to know is how big of a matrix that you have. So let's do a few more.
Back at the computer.
Yep, so I'm going to be going, I know, back and forth a lot. Okay.
I just have the camera pointed to one of those.
Oh, to that. So, okay, so that'll work. Okay, great.
No switching.
Great, great. Okay, so let's try this next one. Here, suppose we did 3x minus 4y equals 1, and 2x plus 3y equals 12. So the first thing we're going to want to do is put this in matrix form. So you have to make sure that your X's and your Y's and your numbers are all lined up, because if not, you need to do some manipulation. Hours for this is all lined up. Then you need to make sure that you're very careful just in writing down and typing in these numbers, because if you put the wrong number in, it's going to tell you the wrong answer. So here again, remember when I need to know how big of a matrix I have, it's rows then columns. So I have a 2 rows, 3 columns. So this is still a 2 by 3 matrix. All right. So now I want you to try to put this into your calculator. And y'all are supposed to bring your calculators today. If not, you're at a disadvantage and you're just staring at me. All right. So here we're going to edit. I still have a 2 by 3, so that's right. But now I'm going to put in my numbers. So I need a 3 and then a -4. Make sure that you choose this negative sign. If you try the subtraction sign, it's going to be wrong. So you have to choose the negative sign, all right? So -4 and then a 1 and then your 2, your 3, and your 12. Okay, so once you have that in there, I do go back and hit the quit key, so that second mode, just to get it cleared off, clear my screen. And then I go back to my matrix and I want it to do my work. So go to matrix and go to math and go all the way down to RREF and then tell it I'm working with which matrix, matrix number 1. And when I do that, that tells me that my answer should be, my X should be 3, my Y should be 2. So coming back over here to the screen, the solutions to this would be rewritten as, what was it? A 3 and a 2. A 3 and a 2. So that's the way that you would write your answer. It's written as an ordered pair, because remember really what it's representing is the point where those two lines intersect. Okay, so this was my X answer, this was my Y answer. Okay, all right. Any questions about that? Have y'all done matrices before? Some people, yes, yes. How about out there? Have y'all done matrices before?
Yes.
Yes. Okay, so this chapter 9, this today should be like easy, right? You're saying no. Have you done matrices before? Before I got it. Okay, that's all right. Okay, so let's look at this next example here. We're going to have 3x minus 2y equals 4 and -6x plus 4y equals 7. Okay, so make sure your x's and y's and numbers are lined up. And this is still a 2 by 3. Okay, so put that in your calculator. Then hit quit. And look at what your answer, does your answer look different that time than it has all the other times before? It does look different. When I try to scoot over to see everything, I'm using my left and right toggles here. So this first row, remember, was only supposed to have a 1, a 0, and then a number, right? That's what it was supposed to have when everything works like it's supposed to. So something is different here. Okay, so when you don't get that 1, 0, 0, 1 on that left-hand side, then that means either you have the situation where they're parallel and they never intersect, or you have the situation where they are the same line. So you've got to figure out from the information given whether you've got the situation where they're parallel and never intersect, or if they're the same line. Well, let's look at what I've got. I've got a 1, and then I've got this negative 0.6666 that goes on forever, and then that says that's equal to a 0 on the other side. Well, that's a problem right there, right? Because remember how it was? You have your 1, 0, 0, 1, and then you get a number on the other side. When that happens, that is not true that 1x plus negative 6y is going to be equal to a 0. This situation is going to tell you that there's no solution. All right, so what you're going to say for this answer over here on my tablet is you're going to say that it's the empty set. That means that there's no solution and that these two lines are parallel. So what I want you to be able to do is to mesh not only algebraically what's happening, but geographically what's happening. Not geometrically, not geographically, geometrically what's happening, right? So here I've got no solution, so geometrically that means those two lines do not intersect, so they have to be parallel, okay? So that's what an answer is going to look like with your calculator there. Now let's do one where they actually end up being the same line. And also, your homework may say, what kind of system do I have? When something is the empty set and there's no solution, that system that we started off with is called inconsistent. So this is also called an inconsistent system. Okay, so when you get empty set, that's called an inconsistent system. So the next one we'll look at will be one where they're actually the same line. So here we'll have minus 9x plus 3y equals negative 24, and 3x minus y equals 8. So still we have a 2 by 3. So let's go in and put those numbers in our calculator. Now on this one, the difference is that bottom row goes 0, 0, 0. All right, did your bottom row go 0, 0, 0 all the way across the bottom? Okay, when you get a row that says 0, 0, 0 all the way across the bottom, that system means that those two lines are actually the same line. All right, so when you get a row that says 0, 0, 0, okay, that means that these are the same lines, okay? Now this means that I'm going to give my answer not as a point, not as the empty set, but I'm going to give it a point. But what I'm going to do is I'm going to come up with another way to write x. Okay, this is how they expect you to do it. And what you do to figure out what to put in the x's place is you just take one of the lines, and clearly the second one looks the simplest, right? And you're going to solve it for x. So I'm going to take 3x minus y equals 8, and I'm going to solve it for x. So I'm going to add y, and then I'm going to divide by 3. So I'll get 8 plus y over 3. So this is another way to write x. So then in this place of the x, I'm going to write 8 plus y over 3. That's how they want you to give your answer. Okay? And so this kind of system is where they're actually always true. There are infinitely many solutions. So there are infinitely many solutions, so that's why I have to write it using variables. It's not just one or none. So that's the only special thing about that. So when you see a row that's 0, 0, 0, 0, that means infinitely many. Okay. Well, what if I have more than 2 equations? I have 3 equations. So let's look at this one. 2x plus y plus z equals 9. Negative x minus y plus z equals 1. 3x minus y plus z equals 9. Okay, what size matrix is this going to be? A 3 by 4, because I'll have 3 rows, 4 columns. This is going to be a 3 by 4. So put all your numbers where they belong. First, make sure that every column, you know, your x's, y's, and z's are all lined up, and everything that's just a number is on the other side. So there are a couple of homework problems where they're not already pretty for you, so watch out for that. So now I'll have 2, 1, 1, 9, negative 1, negative 1, 1, 1, and 3, negative 1, 1, 9. So we'll go through the same process. It's just going to be a larger matrix. So where we get to the edit here, I'm going to change it to being a 3 by 4. 3 by 4. And now I'm going to type in all my numbers. 2, 1, 1, 9. And then negative 1, negative 1, 1, 1. Oh, Lord, I'm getting all kinds of. Negative 1, negative 1, 1. Okay. And do double check behind yourself, because just like that, if I hadn't paid attention, then I wouldn't have the right numbers. So 914, 111, negative 1, 2, negative 1, 3. Okay, so just double check your numbers and make sure you've got them in there correctly. Then I'm going to get it to do the work for me. I want it to do reduced row. All right. So this time, you see the first column is my x's. There's where the 1 is. Wherever the 1 is, that's going to be the answer for my x's. So in this case, we find out that my x is equal to a 2, that my y is equal to a 1, and that my z is equal to a 4. But when I give them my answer, what you're going to do is you're going to write it like a coordinate, and you're going to put it in the order of the alphabet, x, y, z. So I would have a 2, comma, 1, comma, 4. That's how you would write that answer. Okay? Are there any questions so far? All right, so I'm going to give each group a problem to work. So this first one is for Beaufort. This is your problem to work. 6x minus y equals 5, and y is equal to 11x. Notice that yours is not set up all pretty. You need to manipulate it so it's set up like you want it to be. So that's Beaufort is number 1. Ocracoke, you get number 2. 3x minus y equals negative 4. And x plus 3y equals 12. So that's Ocracoke. Number 3 is Plymouth. 9x minus 5y equals 1. Negative 18x plus 10y equals 1. Number 4 is Columbia. And this is 3x plus 5y equals negative 2. 9x plus 15y equals negative 6. And then, Madam Mesquite, your number 5, 6x plus 7y plus 2 equals 0. And 7x minus 6y minus 26 equals 0. Yours also is not the way it needs to be set up, so there's a little manipulation before you solve it. Okay, so each site, work your problem, put it in your calculator, let the calculator do your matrix. Once you get your answer, I want you to be able to tell me geometrically what that means. Do those lines intersect? Are they parallel? Are they the same line? So I've checked with all the facilitators, and everybody should have a calculator. And then if you're in here and you don't have one, then you need to make sure you see me after class, okay? So as you're working, I'm going to be just talking to you in general. On Friday, we should complete all the information for the course. So I should finish the course's information on Friday. Monday will be review day, and Wednesday will be your test, all right? So a test a week from today. So make sure you've got your homework done, and there's a review. All that stuff is opened up, okay? So make sure you're looking at that. And then what we'll do the next, after the Wednesday on the test, then we're going to spend those next 2 days, that last Friday and that Monday, reviewing for the final. There will also be a final for review that's opened up for you to look at. Okay, so that will also be available. All right, Beaufort, were you able to do number 1? Anybody willing to tell me what I needed to do before I could start number crunching this thing? What do I need to do? Switch them around. So that 11 needs to be moved over to the other side, right? So ultimately, you should have negative 11x plus y equals what? 0. So once you've done that, then you could have that, right? And when you put it in your calculator, what did you get for your answer? Negative 1, negative 11. So negative 1, negative 11. So what does that mean graphically about those two lines? Yes, they intersect at that point. So that's what it means graphically. And it also means if I were to go back to these original equations and put a negative 1 in for x and a negative 11 in for y, it would make both of those equations true. Okay? Yes?
I put a positive 11 and a negative 1, I still got the answer.
You put in a positive 11, and well, you just probably coincidentally got the right answer. That probably won't always happen, right? So you do want to make sure, yeah. Right. Okay. Ocracoke, were you able to finish yours?
Yeah.
We did.
Okay, awesome. What did you get for your answer?
Do you want the entire matrix, or just what y and x need to be
Okay,
equal
tell
to?
me what your matrix was first.
1, 0, 0, and 0, 1, 4.
Okay, so you put it in your number crunch, that's what you got, and so from that, you found out that what was your answer?
When x is equal to 0, y is equal to 4, the
Perfect.
graphs intersect.
Yes, exactly. So they got the coordinate 0, 4. That means those two lines intersect at that point. Okay, very good. Thank you, Ocracoke. Okay, Plymouth, were you able to do yours?
Yes.
Okay, what did you get for your answer?
0 and 1.
Okay, so what you put in was a 9, a negative 5, and a 1, right?
Right.
A negative 18, a 10, and a 1.
Yes.
All right? Yes. All right, now when I'm going to follow you because I want to watch this one work. And this is a 2 by 3. And so you have your 9, your -5, your 1, -18, 10, and 1. Right? Get there in a minute. Okay. Did yours look like this? You have a 1 and then a -5, ... and then a 0?
Yes.
And then a 0, 0, 1?
Yes.
Yes. Okay. So when I see this crazy thing happening, like instead of a 1, 0, and then a number, when I see that happening, I know that either I have no answer or infinitely many solutions. This bottom row here, for example, will tell me I have 0, 0, and then a 1. That's telling me that 0 is equal to a 1, which is false. Okay? So you've done everything right. It's just interpreting the results. So here your interpretation should be empty set. And that's because your answer, when you looked at it, this bottom row said 0, 0, 1. If that bottom row had said 0, 0, 0, then it would be infinitely many solutions. But because it said 0, 0, 1, 0 is not equal to 1. That is false. And so you did everything else beautifully. It's just we want to say that our answer is the empty set. Okay? And because it's the empty set, then that means they're parallel. All right, Columbia, were you able to do number 4?
Yes.
Yes. All right, when you did number 4, what did you get for your answer for number 4?
We got that the 2 are the same line.
Yes. So you got the 2 are the same line. So when you looked at your matrix, did that bottom row say 0, 0, 0?
Yes.
Yes, so that's how I knew that. And then how did you give me the answer? Do you know what to do?
Not really.
Okay, that's fine. You put it in your calculator correctly. You were able to interpret it correctly. You knew that there are infinitely many solutions. That means they're the same line. We just need to now know how do I want to write my answer. We always just put a y in the y's place, and then we choose either the first equation or the second one. I'll just choose the first, and you take the first equation and you solve it for x. So 3x plus 5y equals -2. So 3x is equal to a -2 minus 5y, and then divide each side by 3. So we'll have a -2 minus 5y divided by 3. Okay? So when it's infinitely many, you just choose either one and solve it for x. And what you get is what you put in that first place. Okay?
Okay.
All right, very good. All right, number 5. Madam Mesquite, were you able to do number 5?
Yes.
Yes, okay. Let me erase this little part right here. What did you get for number 5?
We got x as 2 and y as -2.
All right, good. That's exactly right. So you've had to first move the 2 and the 26 over, right?
Yes, ma'am.
Yes. So once you do that, you can number crunch it, and it tells you that x is 2 and y is -2. All right, now I've got one for everyone to do. So if everybody would try this one, please. This is a 3 by 3. A 3 by 4, excuse me. Yes, you have a question?
Never mind.
Okay. Okay, when y'all put this in your calculator, your left-hand side should look like 100010001. And what do you get for the first row? What was the top number that you got there?
2.
2. How about the middle one? 1.
1.
And the last one?
4.
Perfect. So when I write my answer, I'll say 2, comma 1, comma 4. That's your X, your Y, and your Z. Okay? Any questions about that? So when you have on the exam a system of equations and it says solve using the substitution method, you can solve using the substitution method, and you could also solve it using this method. Okay, so this method is always available to you because you have your calculator. All right? Any questions about the matrix and using it with your calculator to get it to tell you? All right. Now, I know that you've seen before now application problems. And suppose you had one that says the sum of 2 numbers is 47. And the difference between them is 1. And they want us to find the numbers. So when you read application problems and you see 2 totals, do you see one of them says, hey, if I add them, I get 47. If I subtract them, I get 1. That's like 2 totals. So I can make 2 equations, and there are 2 unknowns. And I've talked about that a lot. You know, if you only have one equation, you better figure out how to write it so there's only one unknown. But now I could write 2 equations using my 2 unknowns. So if I just say, let's let x be the first number, and let's let y be the second number, right? Or one of the numbers. That means if I add them together, I should get 47, right? And if I subtract them, I should get 1. So I created a system of equations. 2 equations, 2 unknowns. Now, even if I have this, I could go through the process and either solve it by substitution or solve it by elimination, but I can also solve it using a matrix, right? Because we've learned that. So what I can do now is write this as a 1, 1, and a 47, a 1, negative 1, and a 1. Okay? Try that in your calculator and see what you come up with. Okay, did your left-hand side have the 1001 going on? Awesome. What was the top row? What was the number that came there that you got? A 24. And what was the one at the bottom? 23. So what does that mean the value of x is? 24, because this was my x row, so there's my x's. And my y is going to be 23. So I was able to solve an application problem, writing it as a system of equations, and then just letting my calculator use the matrix to tell me the answer. Right? Ooh, use the matrix. Y'all ever watch that movie, The Matrix, and all those? Yes. Yeah. Yeah. I've watched them lots of times because my husband loves that movie. Movies. All right. Any questions about any of that? Awesome. So practice getting your calculator, knowing how to put it in there, because I know that there are at least 2 of these on your final, and that may not sound like a lot, but when there's only 20 questions, if you get those 2 right, that's wonderful, right? So make sure you know how to do that. Okay? Does anybody have any questions about anything? Keep up with your homework. Some of you are still way behind. Okay? All right. I'll see you Friday.